The drive shaft in front of us broke due to the owner's aggressive driving and taking a corner in a drainage area. To save money, the owner opted for repairs. Looking at the brake, it's clear that glue won't be enough to fix it. However, after inspection, the craftsman said it's not a big issue and can be repaired for just 2,000 rupees. Since the bearing housing is an oddly shaped part, it's difficult to fix on the lathe. But the Pakistani craftsman already has a plan. He welds an iron pipe to the back of the bearing housing. Later, this pipe will be secured in the lathe chuck to find the center point of the drive shaft. After welding, the craftsman reconnects the two broken sections of the shaft and uses a caliper to measure the original length, ensuring that the repaired shaft will be the same length. The craftsman then starts the lathe, using a tool to remove the excess material from the broken surface. However, the hardness of the drive shaft material makes it difficult to machine with a regular threading tool. So, the craftsman uses an acetylene torch to heat the half shaft, annealing the metal to soften. This allows him to smooth the surface with the lathe tool. In preparation for welding, the craftsman also performs chamfer cutting to create a beveled edge, increasing the contact area for the weld. To ensure the two sections of the shaft align perfectly during welding, he drills a hole in the center of the shaft for the connection, then enlarges it with a twist drill. After each cut, the craftsman checks the hole with a caliper to avoid any size discrepancies. Since the shaft has become shorter due to machining, the craftsman finds a suitable steel rod for the joint. He machines the rod to match the diameter of the bearing housing hole, creating a male-female fit that increases the overall joint strength and concentricity. During machining, the craftsman frequently measures to ensure all the dimensions meet the requirements for the joint. Once machining is complete, the parts are ready for assembly. Since the length has already been measured, the craftsman taps the steel rod into place with a mallet. After assembling the parts, the welding begins. After each weld layer, the craftsman hammers the surface to remove slag. This process not only releases the internal stress from the welding, but also prevents impurities from entering the weld, ensuring a high-quality joint. After welding, the extra steel rod is trimmed off, and a protruding section is left for the next joint. Once the external dimensions meet the joint requirements, the craftsman machines external threads onto the protruding section to increase joint strength. Using skilled control of the threading tool, the threads are machined onto the shaft. After threading, the excess steel rod is trimmed off and the bearing housing is complete. Next, the craftsman processes the other end of the shaft. The process is similar. First, the shaft is heated with an acetylene torch to reduce its hardness and speed up the machining. After heating, the lathe machining begins. Since the steel rod has already been threaded, the shaft needs to be machined with internal threads to match, ensuring the threads fit perfectly together to prevent future breakage at the joint. To ensure the weld quality, the craftsman stops after each layer to hammer away the slag, preventing inclusions. After welding is complete, the excess material from the weld is ground down with a lathe tool, making the surface smooth and flush. At this point, the drive shaft has been fully repaired. What do you think of the craftsman's skills? If you had to rate it out of 10, how many points would you give?